Has everyone filled out the attendance? Okay. Did anyone find the flag hidden on the website? By the way, we moved to ctf.greyhatgt. Shit, am I muted here?
Oh, I can hear you.
Okay. Yeah, I think everyone online should be able to hear me. We moved the domain of our CTF platform to ctf.greyhatgt.org, and our main website is now on greyhatgt.org. If you remember from the last time, 2 weeks ago, the main website is open source, so you guys can see everything that happens to the website on GitHub. So we're going to be putting the flags on the CTF website from now on, just so we don't spoil it. Did no one find it? Okay, I'll show you guys where it is then. So if you go to ctf.greyhatgt.org, you go on here and then you do inspect element. Let's reload the page so that we can see all the requests that are coming in. So you guys might know from the title slide, this meeting is about HTTP. So if we look at the request here, and then we look through these headers, right, we can see a secret flag. So that's where it was hidden. Okay. Thank you, Kevin. Let me turn off my notifications. Okay. We're going to come back to the CTF website later when we're going to go over some challenges that we're going to do based off of what we learned. But for now, let's just do the club updates, and then we'll get into learning about HTTP. Okay, so we have a few open roles. The LLM CTF agent, we're going to have the applications through that Google form there, and they're going to be due on Friday. I'll send out another announcement after the meeting, just a reminder. And we're also looking for challenge authors for Rec CTF, which is a CTF that we're going to be hosting in about a month from now. If you have previous experience in CTFs or writing challenges, we are very much in need of people to write more challenges. And you can ping me on Discord if you have any questions. Okay, so a little bit of info about when we meet. We meet 6:30 to 7:30 p.m. every Tuesday and Thursday. Tuesday meetings like this week are going to be CTF technical meetings. We're going to alternate between me and Sean. And Thursdays are going to be general and social meetings. We also have a Google Calendar that you can find on our website that will allow you to subscribe and have every event in your calendar and get notifications and stuff. So we're thinking of doing midnight CTF this weekend. Not completely sure yet, but we'll post an announcement if it ends up happening. Also, DC 404, which is the DEF CON local group that meets every third Saturday of the month, is going to be meeting this month on March 21st. That's going to be the Saturday, like the weekend right before spring break. So I won't be here because I'm flying back on Friday. But if any of you guys are around at that time interested in going, it's pretty convenient. There's a bus that comes right to Nav and takes you right in front of where they're meeting. It's a place called Manuel's Tavern. You can just find it on dc404.org, I think, just their website. But the bus takes you straight there and then straight back, and it's very convenient. They'll meet there from 2 p.m. to 5 p.m., and they have a bunch of fun stuff. Last time I went in January, and they had a King of the Hill network CTF, and they also had a bunch of locks and lock picking, and they had a little mini presentation about open source CAD software. So it was pretty fun, very chill, not very serious at all. You just go there, you can just hang out. We had a CTF this weekend, a DICE CTF. If any of you guys solved a challenge and want to be featured on our website, all you have to do is fill out this form and submit a write-up. Okay. So some of the things that you're going to want to have if you want to follow along for the meeting are Wireshark, Burp Suite. I probably won't be using that because it's a little bit finicky on my version of Linux. Most of the stuff we're going to be doing, you can just do in the browser console anyway. You don't need like specialized tools, but it is very nice to have. And curl, which you should probably already have pre-installed. And we're going to be looking through some challenges on the Portfigure Web Security Academy website. So if you have a free account, that's great. Yeah. If you guys are on Linux, you can probably just like put these into an install command and let that run in the background. If you're on like Mac OS or Windows, those have package managers too, I guess. But you might be clicking through a lot of menus. Okay, I'm just gonna keep going. If you guys want to follow along, or if you already have those downloaded, you guys can do that. But I'm not gonna spend a lot of time waiting for you all to download all of them and set all of them up. Um, yeah. Okay, so I'm gonna first start at the very basics. HTTP stands for Hypertext Transfer Protocol. So just in the name, you should know that it's based on text, right? So everything in HTTP is all text and it's hypertext. So it's not just plain text, but there's a lot of formatting and additional information in there. So it's an application layer protocol, and it has a client-server model. So your device is the client, and you're talking to a server. And there are requests and response. So you send a request to a server, a client sends a request to a server, and the server responds with a response. And every request is independent. So if you want to remember something from a previous request, you have to send some sort of ID or some sort of information from the previous request if you want to have that. But every request is independent. And it sits on top of TCP for how it actually is routed. I think Sockets went over at the last meeting when he talked about air snitch, all of the different layers of the networking. But yeah, and also use TLS for encrypted HTTPS. Okay. So yeah, so there's been a lot of different versions. Most recently, we have Quick, which is UDP based, and they have faster handshakes. But it's a very old protocol. It started back in 1991. I'll fix that formatting when we publish the slides. But yeah, and then it started off with just GET requests, and then they added more sorts of stuff. And if you don't know what like header status codes and content types are, we're going to be going over those a little bit later in the presentation. Okay, so just so you guys can see what an HTTP request looks like, what's the best way to do this? Let's go here. If I open, okay, yeah. I'm going to open up Wireshark and show you guys like a request that I'm going to capture. So Wireshark is a program that listens in on your network interface, right? The network card on your computer, and it intercepts all the traffic going through it and allows you to inspect and see what's going on. By default, it'll just work on your computer. I think there are ways to plug in external antenna and snatch out some packets that are going over the airwaves from other people's computers, but we're just going to be working on our own computers for now. You are going to have to run it as root, sudo, or like some sort of privileged user because it's going to be capturing the data from like other applications and everything going on your computer. Okay. Yeah, I deleted, that's just Pico CTF key. Let's see. Okay. So this is my main network interface, right? So let's start capturing on there. And then let's filter by HTTP. So you can see nothing really showing up. Most stuff on your computer hopefully is going through HTTPS, so it's encrypted, so random people can't see what's going on. But if we go to a site like neverssl.com, right? That is a site that's explicitly designed to never use HTTPS. So it'll always use HTTP unencrypted plain text. And in my other browser on the other monitor, I just went to the website. It's loading. Why is it so slow? Hopefully in a second now it'll show up. Do I have to? It's what? Yes, it was supposed to be loud. What's happening? I did it right before the meeting and it worked. Okay, there. Okay, I just had to reload the page. Okay, so let's go through what it just sent over. So let me make this bigger. It's a little bit hard to read. Okay. But what you can do is you can see all of the raw bytes and stuff that's being sent over right now. But just to make this a little bit easier to read, what we can do is we can do follow. Because remember, HTTP goes over TCP, right? But TCP splits it up into multiple requests. But see, so there's like multiple TCP requests, even there's only one HTTP request. But we can do follow, and then HTTP stream, and then it'll give us the full stream. So like we said before, right? We're going to go over what each of these things lines here means. But as I said before, HTTP is a plain text protocol, right? Well, not plain text, but it is just UTF-8, regular text. So all the information here, none of it's like binary encoded or everything, is just in regular text. So the red part here is the request. You can see at the bottom it's color encoded, right? So the top here is the request, what we send to the server, and the blue part is the response, what we get back. And you can see there's the whole website. And I'm going to go over what each of these parts means a little bit later. Okay, we can close this down for now. Okay, yeah. So you can see the request line, the headers, and the body. And anyone on the network can also read this because it's also HTTP, not without the S, so no TLS. So if you remember when we had it up, we had something that looked a little bit like this, where there was a method. So it was get, we're not actually post in this case, and then it was the route that we were going to, the HTTP version, the host, and any headers. And then we had the HTML response. Here is JSON, but we had HTML there. So yeah, 3 parts: the request line, the headers, and the body. Since we sent a get request, there wasn't actually a body there, but there can be a body. Yeah, so if we go over the different HTTP methods, right, we send a get request that didn't have a body. There are also post requests to submit data, and that does have a body. Put, patch, delete, head options. Technically, you can put any string in the method field. So there are some non-standard methods, but these are the main ones that are universally used. And options is a special one that just returns what are the valid HTTP methods for this route. Yeah. And if you remember from the history, get was the first one. For some time, it was the only one that was supported, and these other ones got added on later. So this is a little bit about the structure of a URL. When you go to a website, right, you first have the scheme, which is HTTP or HTTPS, and then you have the host, which is like a domain, and you have the port, and the path, and then the query string and the fragment. So everything after the host and the port is just sent to the server, and the server figures out what to do with it. So although the path, query string, fragment, all of those are like separate things, really the only thing, the scheme determines what sort of protocol you use, and the host and port decides who you send it to, and everything after that gets decided by the server that received them. No, it's all good. Yeah. Okay. Yeah, okay. We'll just keep going. Okay. Something that's not mentioned here is that sometimes you can also have a username and password. So right before the host, you can have some name at like something else. And then, yeah, so that can be like username and password. You put the username in there, and then I think the password gets typed separately. But that's often used in phishing campaigns. So something you could do is you could put a username that's like Microsoft, like official something, and then people aren't going to read like past towards the end, right? They're just going to read the initial part, right? So you could put like something that looks like a URL in the beginning, and you can have an @ and then you can have the actual URL at the end. So yeah, another thing is like authentication over HTTP. A lot of times you'll use like cookies or an actual login site, but if you want to send the authentication directly over HTTP, there will be like an authentication part before the host. And the other thing is a lot of stuff is escaped here. So like spaces get replaced with %20, // get replaced with %2f. And that's just because those characters like / has a special meaning, and space could lead to some confusion whether that is actually part of the URL or not. So that's called URL encoding. Basically, it's a percent, and it's the hex code of that character, if you know how ASCII or UTF-8 is encoded. Okay, so if you remember when we saw HTTP request before, we had get and then the path, and then we had the version of HTTP, and then under that, that was the request line. Under that, we had all the headers, right? So these headers can be any string that you define, right? So host is required, but the other ones are just any string, any piece of text. So these are some common ones that are standardized and agreed upon, and there's a lot more that are standard, but you could really put anything you want there. So user agent, for example, that's how a website might know if you're on Chrome or Firefox and what version you're on. This is used a lot of times for fingerprinting, right? To know, what person is coming, even if they haven't signed in. CLI tools like curl will set a custom user agent. If you know Google Scraper goes and scrapes all the websites for their Google search, they have a custom user agent, so the website knows who's actually trying to talk to them. Accept is what types of responses the client will accept. So if you will accept HTML, that's usually the one you want when you're going to websites. Some of the LLM bots will say we also accept Markdown, so they would prefer that, and they'll say we accept Markdown, we prefer Markdown, but we'll also accept HTML. If you're requesting an API, you might say you want it back in JSON or YAML or some other kind of format like that, or XML. And content type is what you're actually sending to them. So accept is the response type, and then content type is the request type, what you're sending in the request body. So that could be like JSON, YAML, XML, anything like that. Authorization is usually some sort of token that you're sending, and cookie includes a bunch of all the cookies. I'm sure you guys know what cookies are. It's just some plain text state. And then X forwarded for, usually you're not connecting directly to a web server. You're connecting to a reverse proxy or some series of steps in the middle to get there. For example, you might have a load balancer where everyone connects to one load balancer, but distributes among multiple servers. If you have a bunch of different servers and you want to distribute the load, so the web server that ended up finally processing the request is not going to be connecting to the actual IP of the client who initially requested it. So the proxy in the middle will add X forwarded for where the request actually came from, the real IP. But you can also set custom HTTP headers when you send it to when you send the request. So we can see in the future, if it blindly just trusts X forwarded for, you could set your IP to something else and pretend to be someone else who you aren't actually. So we're going to see a little bit more of that later. Yeah, okay. So what you can do is you can spoof X forwarded for to set your IP to something that isn't actually your IP. Let's okay, so sometimes what an app might do is say, we have an admin panel, but it's only allowed for people on localhost, right? People who are already on the machine, they already have access, so it's just for like maintenances and stuff. But it's not for external users. So it'll be limited to 127.0.01, which is the same IP as localhost, and otherwise it's returns forbidden, right? Another thing that you can see is it might be used for rate limiting. So they might count the number of requests a certain IP has made and use that to make limits. If you, for example, you're trying to log in a bunch of times into a login form, they might use that for rate limiting. So there's a couple labs on PortSwigger. I think we might come back to this later. I'm not exactly sure how much time the rest of this is going to take because we have a lot more slides. But if we have some free time at the end, we can come back and walk through these labs. But if you have some time after the meeting, I would definitely recommend that all of you guys go through these labs. They're super basic and start at a really low level and teach you step by step all of these techniques. But yeah, those are the two that we just went over, which is accessing the admin panel by spoofing X forwarded for, and also bypassing a rate limit. Okay. So let's talk a little bit more about how the request body can be formatted. As we said before, there is content type, which determines what the the request body can be. But there's also URL encoded form data, which is if you have like a post request, usually if you have like a built-in form and you use the form tag on an HTML website, and you say like submit to this URL, that's how it's going to send it by default. It'll say in the body, it will have the URL encoded, what's basically the same format as query params in GET request. And it will be sending the content type as application forming URL encoded. A lot of times, most of the times when you're dealing with an API, you'll send JSON. And also, the other thing is if you're doing file uploads, or if you're doing some sort of very complex form, you can have a multi-part form data. And basically, there are different boundaries, and you can have different like streams of data. So this is mainly used for file uploads. So yeah, let's see. I think we'll skip this for now and come back to it just for time. But this is a simple thing that we can do where we can send a post request by hand and see it show up in Wireshark. So yeah, HTTP bin is also a really nice site for just testing out different stuff with HTTP. Yeah. Okay. So the response structure is very similar to the request structure. The first line is the status line, so it has the version, and then it has the status code, and then the status like word or name. So if you know status codes, 200 is okay. Anything in the 200 range means everything's good. 300 range is like everything's good but something else. Like 301, I think, is for like a redirect. Actually, that's 302, I think. 302 is a redirect. 400 is an error and it's your fault. So like 404 means you went somewhere that didn't exist. 405, I think, means you sent something invalid. 403 means forbidden. 500 means something went wrong and it's my fault, the server, right? So 500 error means there was some internal server error. We don't know what happened. I don't know any of the other 500 error codes, but yeah, so those are most of the standard ones. And then I think 100 is usually used for like version upgrades or like if you want to switch protocols, something like WebSocket, I think, or if you're like upgrading to HTTPS, I think that usually goes through 100 level status codes. Yeah, but you can go on MDN and see all of them. I think funny one is I think it's 419. I don't know if you ever heard of HTTP 419. It's I'm a teapot. It's an April Fool's joke. Basically, it says you sent a request to a teapot and I cannot brew coffee. Server error. That's officially in the specification. So all your programs should handle that. So yeah, after that first status line, we have the rest of the headers. So you have content type, set cookie, and cache control. So those are a few common ones. Content type, we went over that before. What is the actual, how should the response be parsed? Because certain responses, especially in certain attacks that you might specifically craft, they can be parsed in multiple ways. You could, for example, put together some sort of response that could be valid JSON, but also a valid like file, a certain file type or something. Yeah, you could have okay, and then set cookie is just tells the client to set a cookie and send it on every response that it sends in every request it sends in the future. And cache control just says how long to cache. And there'll be a blank line, and then there'll just be the body in whatever encoding format. HTTP doesn't care; it's just text, and it's not going to enforce a specific way of doing the body. However you want to format the body, you can do that. Oh yeah, okay. So here, these are status codes. So I only thought of 500, but there's also bad gateway, service unavailable. Yeah, 301 is moved permanently. 302 is found. 304 is not modified. Yeah. Okay. So a little bit more details about the status codes. 401 is unauthorized, as in you're not logged in. But if you log in, you might be able to access it. But 403 means we know who you are and we know that you're not allowed to access it. So yeah, so 403 is that something exists but you're not allowed to access it, and then 404 says that nothing exists, although it might exist and just you can't access it, but maybe they're just giving you 404 anyway. But yeah, 404 is supposed to mean that nothing exists, but some people use it also for you're not allowed to access this. And 500 can sometimes really reveal like error information or stack traces. but most of the time, this hopefully should not be happening if you make your app properly. On production instances, it should not be giving out error data. Okay. Yeah. So let's see. Another type of attack is called an open redirect, where you have a website that redirects you to somewhere else, right? So if you know how Google scans all your emails, right? And what they do is they actually replace all the links in your emails with google.com/redirect and then the actual link in the email. And they go in and they change all your emails like that. And that's how they know everything that you click on and stuff. And also the people who send the emails have a redirect so that they know when you click your email. So you go through probably 2 hops before you actually get a link on your email. And then if you have something like Microsoft Outlook or something, right? They have a safe links proxy that they add, which actually scans the a website that you're going to before they redirect you to the site. So Microsoft Outlook will also change the links and stuff. If you go to Google.com, right? Actually, I'll show you. You go Google, and then you search for "Hello World," right? Okay. I try to click on a link here, right? You can see in the bottom left, it shows en.wikipedia.org, right? Can you see that? Oh, I think it got cut off. Okay, got cut off on the projector. But when you hover over a link, it'll tell you. So this is a link to Wikipedia, right? But when I'm about to click on it, I click copy link, right? I paste this here. I'm pretty sure. Okay, never mind. I think this used to happen before. Never mind. I think Google used to add some sort of redirect link, and they would do it right as you click on it, right before the link actually got copied. They would switch it out so that you couldn't see in the preview that they were adding a redirect. I noticed this randomly a while ago, but it seems that it's changed since, or it might be one of the browser extensions that I have that are filtering it out. Yeah. But you guys can try that out and see. So I know one attack I saw in the news was that TikTok had a open redirect where they would just redirect anyone anywhere, and they had a / redirect, and then you could just put in any URL and you get redirected there. I know a lot of phishing attacks use that to bypass filters and stuff, where they'd say, "Oh, this is a TikTok URL, it's fine," but in the query parameters, it had a link to a attacker-controlled website. When the person clicked on it, it would just redirect them to the attacker website. So this is actually used a lot in the real world. Yeah. I think how many slides do we have left? Yeah, okay. We have a lot of slides left. Okay, I'm going to skip this exercise as well. Yeah, we'll come back to this if we have a little bit of time, but we have a lot of stuff to get through. So yeah, these are some response headers. I think I went over most of them. Content security policy is something that we'll go over later. It's a little bit more relevant to cross-site scripting. And then, yeah. And then, yeah, we'll cover the other last few later. So the way cookies work, I went over it a little bit before when we talked about a sample response, is there's a set cookie header returned, and then the client reads that set cookie header and sets that cookie, saves it in their cookie list, and then every time they send a future request, they send that cookie with the next request. And this is a little bit about how we store state in HTTP, because as we said at the beginning, HTTP is stateless. So unless you include information about who you are and what your previous requests were in your request, the server's not going to know that. It forgets between every single request. Thinks you're a new person. All right, so it's the cookie is included on every subsequent request. And some of the things that you can include in the cookie are path. It doesn't just have to apply to the whole domain. It could apply to certain paths under the domain. You can say it only on HTTP. Or it's secure. I think there's also something you can do where it's so HTTP only. What that means is the JavaScript on the page can't access the cookie. So if you have maybe you get XSS, right? You get cross-site scripting. You have the ability to execute JavaScript on the client, right? But certain cookies you still can't access. Something like an HTTP only cookie that's only sent on the HTTP request. But in the browser console, if you do document.cookies, you can't see it. So if you are doing some sort of challenge or attack where you need to do XSS, you're probably going to have to find another way to get the cookie, maybe by making some sort of request to somewhere that like returns the cookie. Or usually what you'll do is you'll do everything you need to do with the cookie and just return the final payload, final result. But if it doesn't have HTTP only, you can just bring the cookie back to yourself and then pretend to be the client and just get all the data you need, which makes it a lot easier. Yeah. So cookies, they're usually some sort of random session ID, just a random number that says that an ID that identifies you. Another thing that websites often do is something called a GWT, which is a JSON Web Token. So basically, in this situation, the server doesn't need to remember anything. Usually with a session ID, the server will have a database, and it will say this session ID is this username, this email, and this preferences, and all this stuff, right? And then every time you send the cookie with the session ID, it'll look you up in the database, and then it'll have all the information about you. The thing with the JWT is that the client stores all the information for the server. So it says, I am this username, I am this email, I have all these preferences and these settings that I want, and all that stuff. But the thing is, you don't want to just send that, in regular text. Otherwise, you could just edit that. You could just say you are anyone or have any preferences or, are an admin or something. So what the server does is they cryptographically sign it with a secret token, like some secret key. They'll cryptographically sign it. So if you edit the cookie and you edit the JSON to be like, I'm an admin, when you're actually not an admin, the signature will not be valid. So the server will know that you tampered with it. So that way you can keep all the information on your machine and the server doesn't have to worry about that. But the server still knows that all the information that you're giving it about yourself was approved by the server at some point in the past. So it'll have, I think it'll be for, JWTs are usually formatted into 3 parts where they have a dot, like a period in between each part. Each part is base64 encoded. So they have, JSON set of data, and then they have like the signature, and they have like an expiry date, and then the signature like encryption format, or the signing, like the algorithm that we used, because there are multiple different algorithms that you can choose from. So that's the sort of data that will be in the JWT. And you can just base64 decode it if you want and just look at it. It's pretty fun. Just go to a website that has JWT and just decode it and see what sort of information they have in there. Yeah, so these are the different attributes that a cookie can have. So secure means that it's only sent over HTTPS. So as you can see, HTTP is all in plain text, so we were able to see the contents of an HTTP request. So there are certain attacks where you can do an HTTP downgrade, where you can convince a client that was normally on HTTPS to downgrade to HTTP and then get out their data. But if you have a secure only flag on the cookie will not be sent on unsecured requests. So you're protected against that sort of attack. HTTP only, I talked a little bit about this before. It's not, these sort of cookies are not accessible in JavaScript. So that protects against, any sort of attacker that might have access to your web page over JavaScript, which is very common in XSS. Same site says that if there's another website, so it says that if you are making a request to like another website, don't send this cookie. So yeah, that's pretty obvious. You don't want your cookies going to some other website most of the time. Usually you set a cookie so that you can remember your user, not so that other sites can see that. The domain, the path, and then expiry, because it'll say when it expires. Let's see. I'm going to, again, skip the attack. I'm going to come back and do all the exercises at the end, just so we can get through all the content first, and then we can go through the exercises at the end. So as we saw in the beginning, right, if you just send an HTTP request, anyone can see it. It's all in plain text. And anyone can also read, modify, or inject content. And then TLS is transport layer security, which is just an encrypted, it replaces TCP, like underneath HTTP. All the content of HTTP itself is the same, but it's being sent over an encrypted channel. So this is how TLS works. I'm not going to go into all the cryptography, although that's pretty interesting. Basically, you send an acknowledgement first back and forth just to set up TCP, and then on top of TCP, you set up a TLS or SSL like handshake. Both the people call it both. But first, you send a client hello, and then the server sends back a server hello and a certificate. If if you've heard about certificate authorities, that's basically how the server says, I am actually, the server. So, you know, Let's Encrypt is the most common certificate authority, but basically there's a chain of trust all the way up to a root CA, certificate authority, that's pre-installed on your device when you get it. And then that root CA signs other top level CAs, which sign lower level CAs, which then sign a specific website owner. So like something like Let's Encrypt will verify that I own the domain. Like for example, GreyHatGT, I had to fix the SSL. I don't remember if you guys remember a few meetings ago, like at the beginning of the year, all the SSL was broken and said this website is impersonating someone else or something, right? All of our certificates expired. So what you have to do is you have to prove that you own the domain either by adding a DNS record or a specific token into our website. And then it'll check that you actually own the domain, and it'll give you a certificate that you can use to say, I am actually this website, right? And that's signed by another CA, that's signed by another CA, and it's a chain of trust that goes all the way up to the root. So the server sends back the certificate, the client validates the certificate, and then they perform a key exchange. So at this point, this is still not encrypted, right? At the very bottom, we have encrypted application data, but at this point, this is all still plain text. Anyone can see this. So the question is, how do we get an encryption key that we both know, but when anyone else can see everything we send? If I send you an encryption key, say, let's use this, anyone on the network can still see that because this is still unencrypted. So there's something pretty cool called Diffie-Hellman key exchange, where basically you have asymmetric encryption, where there's a public and private key, where anything that the private key encrypts, the public key can decode. Anything the public key encrypts, the private key can download. But you can't use the same key for each, right? So it's asymmetric encryption. You have two keys, and each one decodes the other. So the client sends their private public key over, and the server sends their public key over. And using a little bit of cryptography that I don't really understand well enough to explain, and would take a long time anyway, they're able to get a shared secret on both sides, but anyone listening in the middle could not tell what they got. So it's pretty cool. I would recommend you guys watch video or look into it. But yeah, that's how they get a shared key. Yeah, they also negotiate the TLS version, and there's also multiple ciphers that they can use. I think Diffie-Hellman is a pretty good way to get a shared secret. But once you get the shared secret, what sort of encryption algorithm do you want to use with that shared secret? Because there are many ones that you can use. Okay. I went over this mostly already, but there's a certificate binds a domain name to a public key, and it's signed by a certificate authority. And the certificate authority has its own certificate that's signed by intermediate CA, which has certificates that's signed by root CA. So it's a chain of trust that goes all the way down. So you trust one person, and based on those people that they trust, you know that they're also trustworthy, and so on down. So you can also have a self-signed cert, which is not, validated or verified by someone else that is externally trusted, right? And that's called a self-signed cert, and that's the kind of browser warnings that we were getting at the beginning of the year, but we got that fixed. Strict transport security is basically just saying always use HTTPS. And if there's not HTTPS available, reject it. It's something I have turned on in my browser. I'd probably recommend that you guys do the same. There are some sites that still use HTTP, but that should be pretty rare, and you should be pretty careful when you go into those sites. So yeah. So as I talked a little bit about before, there are certain attacks where you can downgrade the connection from HTTPS down to HTTP. It's called SSL stripping. All right. And the way to prevent against that is for use what is it, strict transport security, HTTP strict transport security. Yeah. So yeah. Okay. Let's see. So content security policy is another header that you saw earlier, and I told you we're going to talk about it a little bit later. It helps prevent against cross-site scripting or XSS, and it controls what the browser is allowed to load. So this is not something that's enforced on the server side. It's a recommendation that the server sends down to the client, and the client self-enforces that. So this is an example of a content security policy where it says, self, default source self, script source self, style source self. So what that means is if there is a script tag inline, like an inline script tag in the HTML, and they have just some JavaScript written, don't use that. It can only load JavaScript from the same domain. Don't allow loading JavaScript from external domains. Don't only allow loading styles from the same domain. So, for example, if you had a like comment box, and anyone can see the comments that you put, and you put like a script tag in there, and you said, oh, send the credentials on this website back to my attacker server, right? Well, when it's loaded on another person's machine, the browser that's executing it is going to see the script tag, but it's going to say, I shouldn't execute this because in the HTTP header, it said there should be no script tags in this response, right? Content security policy said, don't trust any script tags in here. They're not supposed to be here. Also, if there's a script tag that doesn't just define inline JavaScript, but says, go fetch JavaScript from this other server, right? The browser's going to know, oh, don't trust this. This is not supposed to be there. You can add a little bit more detail, right? You can put the hashes of the code that you're putting in. If you're putting in JavaScript and say, only execute JavaScript with this hash. You can also say, only execute JavaScript from these like certain domains allowed. So it just says self, the current domain. So this restricts where you can get script styles, images, fonts, and so on. You can also just report the violations without blocking them. Yeah. Okay. And as I said before, this just runs on the client machine, right? Because this is mainly protecting the client. This is the browser protecting you as a user. But this is not something that the server actually has control over. It's just a recommendation that's sent over. Another thing is X content type options. So we talked a little bit about content type, which is what the response is. But sometimes I think this is just like a legacy feature. I don't know the exact details, but I'm pretty sure just because of legacy reasons, sometimes the browser will interpret it as response as something other than the content type, just because it looks different. Like, for example, if you request a TXT file, but if it has like, a bunch of HTML structure and tags, right? Your browser's going to think, obviously, it's some sort of mistake, and they meant to say it's actually just HTML. But that might be an attacker trying to, execute code on your machine when it's actually supposed to be TXT or something, right? So when you say content type options no sniff, the browser's not going to actually like try to figure out what's being sent. It's just going to take it very literally. Here. So another thing sort of attack is if you have like an iframe. For example, what one attacker might do is they say, I want to impersonate a bank website, right? So instead of, recreating the whole bank website and stuff, I'm just going to make my attacker website, and I'm going to have an iframe, which allows embedding another website within your website. You say, I'm just going to embed the entire bank website inside this website, right? And then whenever the user interacts with the bank website, I can like actually data. So there are some protections in browsers that stop, websites from accessing data inside of iframes that they embed. But it's usually better just to play it on the safe side and just say, my site should never be embedded as an iframe. If it's like something super sensitive, right? You can say this website is sensitive. It should only be viewed on this website, not as an iframe embedded in some other website. Yeah, so this is an example of if you didn't have iframe options, right? And then you have another website that's embedded. Yeah, so what you can do is you don't actually need to read the website that's in the iframe, right? So I give the example of a bank website where the user types in their details and then you're able to explicate the information out from the bank website. Well, what you could do instead is you could just show the bank website as an iframe, but you cleverly position some HTML so that the input box on your website is right above the input box on the bank website, right? So when the person clicks on the bank website and puts in their information, they're actually typing into a form on your website. So you don't actually have to look inside the iframe. So this is a sort of clipjacking where you have HTML that appears like it's part of the iframe, but actually it's on your site. And when the user clicks on it, they don't realize that. So this is an example of there's an iframe here, and there's a delete account, but there's a button on top of it. It says position absolute, so it appears on top, and it has and it says click here to win a prize, right? So the person clicks on that, but really they're clicking on the thing below it. Yeah, because the iframe has opacity super low, so you can't really even see it. But the iframe is above the button, but you see the button below because the opacity of the iframe is so small, so it's like transparent. Some other security headers that are used are refer policy, which controls how much information is sent and refer. So if you go to a website, the client, your browser, will tell the website you're going to, I came from this other website. Yeah, if you're on google.com search, right, and you click on a link and you go to a website, in the refer, it'll say, in the refer field, it'll say, I came from this other website. But google.com could say in its refer policy, I don't want you to tell the websites that people go to off this website that you came from here. And permissions policy restricts certain browser features, and this is XSS protection is a legacy XSS filter. Yeah, so if you do -I on curl, it'll show you like headers and stuff. Okay, so we talked a little bit before about different HTTP methods that you can use, right? So there was get, there was post, put, delete, update, I think. No. Options. I think. I think is post. I think update is separate one. I'm not sure about update. But anyway, yeah.
It's patch.
Patch, yes, patch is the one. Yes, I meant that. Okay. So there's a bunch of different ones, and sometimes there's different parsing of requests based on it. So, for example, if there's authentication, right? Sometimes if it's an app is misconfigured, they will only check if you're logged in on one of the methods. So in this example, you can see on the post method, it says require admin, but if you do get or put or some sort of other type of request, some frameworks will send that request anyway through your logic, but it won't actually check the authentication. Yeah. See, so if you know a little bit about injection, right? Anytime you can put user input into a field like the headers or JSON or HTML, where there's some sort of explicit syntax of user content, and then there's control content, or you can use that syntax in order to break out of the user content and say I am like a control sequence, right? So in this example, what does it say? It says the lang query parameter is being put into the header options for content language. But if you just put a new line in your language and then you say set cookie admin true, right? That's going to go onto a new line and be interpreted as a different header. So yeah. So we talked a little bit before about how I mentioned briefly how certain responses can be interpreted as different kinds of formats. So yeah. So one way you could do that, right, is you can say content length. So you can say my response is only this long, but then send a much longer response. And if you have a difference in how that's interpreted, for example, some systems might just have a hard cutoff. It says, oh, you said you're only going to send 13 bytes. You sent 13 bytes. That's it. We're not reading anything else. Whereas some systems might be like, oh, you made a mistake. We'll just read the full response and use that. And if you might be able to exploit the difference between the two in order to do request bundling. For example, if you have some sort of service that scans for if you're sending a malicious payload, right? And you say, oh, my payload, my request is only the first n bytes, but you have the malicious part after that. It only scans the first n bytes because you said, oh, my request is only n bytes long, but forwards the whole thing along. You can get in some malicious content like that. It's called request smuggling. So these are some more port trigger labs. The Web Security Academy is really great. And they have like walkthroughs and explanations for every single type of attack. A lot of this was based on that, all the resources that I have available. And they have, again, labs for you to practice everything that you learned there. So these are some of the tools I went over today. Wireshark, curl, Burp Suite. Burp Suite is pretty very powerful, used a lot in like actual, web security stuff, but might be a little bit of overkill for the level. Like the stuff on the Burp Suite Web Security Academy stuff, most of the stuff there you can just do in the browser console. You don't actually need the Burp Suite tools, but it's does make it a little bit easier, and it's pretty good to learn. Yeah. So we went over like some sort of curl commands, a bunch of them. These are like just what they actually do. So for example, a head request is like headers only. So that was -I if you remember earlier when we were talking about security headers and we were like giving an example. You can do -H to add a header. And there's all these options here. These slides will be posted, but you can also just run man curl or curl --help in order to see all the options in your terminal anytime. Some Wireshark filters, right? So at the top, you can just filter all the traffic. There's so much stuff coming in. So HTTP is usually what you want to filter it by so that you can just see the plain text ones. If you happen to have, if you remember when I opened up Wireshark earlier, there was an error that popped up that said key not found. It said like Pico CTF key not found. I was doing a Pico CTF challenge like a few months ago where it would give you the TLS key, and then it would give you encrypted traffic, and you had to use the key that you had gotten in order to decode the traffic and figure out what the flag was. So you can decode HTTPS traffic, but you need some way in order to get the key out. Okay, so just a recap, we covered the HTTP request and response structures. We talked about cookies and sessions, and then how to encrypt HTTP with HTTPS, and different kinds of security-specific headers, specifically for like XSS, SSRF, which is server-side request forgery, request smuggling, clickjacking, and so on. So yeah, that's pretty much it. I'm gonna end it now because we're coming close to the end of the meeting. But just a quick update, as I said at the beginning, our CTF platform is no longer GreyHatGT.org. It's now ctf.greyhatgt.org. And we have our main public-facing website at greyhatgt.org. You're probably gonna have to sign in again because the cookies, as we discussed earlier, are scoped to a specific domain, so they are not going to be saved when you go to ctf.greyhatgt.org. Yeah, these are some web challenges that might be I thought were pretty relevant based on what we learned today. Yeah, I think there was don't remember exactly what each one was, but they had some of the same ideas that we talked about. Yeah, and then also if you end up helping anyone else solve some challenges, you can fill out our mentor form to get featured on our website. After you mentor people at 3 different meetings, you can be featured on our website. I think Darshan is the only one up there right now, and he's pretty lonely, so you guys should do that. That's it for the meeting. Does anyone have any questions here or online? I don't think I see anything online. If you guys have any questions, you can just raise your hand. I'll be around.